So without further ado, I want to introduce Christopher Baker, who's one of our senior consultants who has been working with React for the last few years. Today, he's going to show us how React hooks are different from previous paradigms and show actual use cases where hooks simplify things.
As Jason mentioned, I will be covering React hooks. But first, I imagine most of you have played the Portal game, either 1 or 2. One of the recurring themes in this game is thinking with portals. So like the very first tutorial step or two, it's just getting from point A to point B, using a portal. So you're basically thinking in terms of walking, you're just using the portal as a shortcut. But then as the game progresses, you start to use the portals in new ways. You're not just relying on the old methodologies anymore. You're doing new things that you couldn't even do before, such as skydiving, or in a more fun manner, licking your elbow, scratching your back, etc. You're using portals in whole new ways that never even occurred to you before. You've at that point learned to think with portals. Very similar thing happens with hooks. Initially, when you use hooks, you just think about them in terms of lifecycle callbacks, but then you learn that they're different. They're not just a replacement. Before I get in too far, though, I want to talk about what are hooks. Short answer is they let you use state and other React features with a function, within a function. A little bit longer, though, kind of what I was saying before, they provide a new paradigm to approaching stateful ideas in an otherwise stateless function. And this is now the third time I've said it, I think, but they're not just an alternative to lifecycles. They're a whole new tool. They're not just a new tool, rather, they're a whole new toolbox. And I apologize if that squeaking is bothering you. My dog has decided that now is the right time to play with his toys. Anyway, so the core takeaway that I found with hooks is instead of thinking about life cycles and whatnot, think about data synchronization. And when we get into the live coding later, I'll get into that a little bit more. Before I get into any code, I want to do a brief overview of the hooks that you'll use most commonly. The first hook you'll use probably 3 or 4 times more than any other hook is use state. When you call it, it returns the state value and some setter for changing it in the future. The use effect doesn't have any return values. You just give it a function and tell it how often to call that function. Usually that function will have some sort of imperative side effect code, hence the name use effect. If you're integrating with external libraries like Google Maps, you will often find things like this, or if you need to do direct DOM manipulations for messing with animations or something, is another place you'll often use effect. The third most common one, I think, is use context. I tend to see this like once or twice in most projects. It gives you a way to create some context object that can be accessed from anywhere within that portion of the React tree. Whereas use state is only in one place, use context lets you spread it out and access the same value in multiple different places. There are a couple other hooks I'm going to go through a little quickly because these won't really come up later, but they're also used fairly frequently. Use ref lets you create an object that you will constantly have access to. It'll stay the same object for the lifetime. So it's a lot like use state, but that doesn't trigger updates. And we do actually have a talk we did a couple months ago that covers use state and use ref, how they're different, how to use them. We also have use memo, which gives you a memoized value. So you can create if you got some expensive function for calculating some derived value, you give it that function, you tell it what its dependencies are, and it will only recompute that value when the dependencies change, so you're not wasting resources. Use callback is kind of a special case of use memo. It gives you a callback function with a static ID, or static identity, so that you can use it in places where you need that kind of functionality. Use memo and use callback are exclusively for optimizations. If you're not having optimization issues, you shouldn't need them. And we do also have another talk specifically about those two. The last one I'm going to mention today is use reducer. It's very similar to use state, except where use state gives you a value and a setter. Use reducer gives you the state object and a dispatch method. Just different approach to storing your state data. So why are hooks better? First of all, they let you co-locate all your logic related to a specific feature. In class-based components, which you'll see in just a minute, you end up splitting your related code over several different lifecycle functions because you need the unmount, the update, the unmount, So it gets a little bit messy and difficult to keep track of. They're simpler, cleaner, and more easily shareable. We'll see this again in just a moment, when you create all of your logic around hooks and you decide you want to share that, you just move it to a function, and then you can call that function in several different components or several times in the same component. Very straightforward to pull your code out because they're just function calls. There's nothing inherently special about them. And the last one, it's a little bit more abstract, but you get a feeling very similar to higher order components, the way you can share data, but it doesn't pollute your React tree. It keeps your DevTools experience very simple. You don't have to worry about wrapping functions in other functions and creating new classes that extend other classes, and you just return your data. So how are hooks different? This is where some code's gonna come in. So this is a class component. It's a timer. It's got 3 different places where we have to store the related code. We have to create the state. We have to, when it mounts, we do something, and then when it unmounts, we do something else. Though this is a timer, it can also apply to a number of different similar asynchronous type processes, especially if you're integrating with external things like external libraries like Google Maps. If you need to do multiple different things within your component, it gets even more messy because we've got two states up in the top, 2 things in the will mount, 2 in the unmount. In this case, they're just cloning each other, so there's at least a little bit easier to follow. But if one of these was working with Google Maps and another one was with a timer and another one was click handlers, because those get a little bit messy sometimes, you have your code split out over all kinds of different places. This code that we're looking at here, this functional hook, is the exact same thing as that entire class. We've got our state, our use effect, which actually does the work, and then we've got this cleanup function here so that it clears it when we're done with it. Everything's co-located, and if we need to share that logic, we just move it to a function, makes it easily shareable. We just call that use timer that we just created with our delay, and it works exactly the same as it did before. And if you want to use it again, you can. You can use it as many times as you want in this function without duplicating that code. You can use it in other components, no limits like that. Now we're gonna do the thing that's always risky and do some live coding. Before I get in too far, I want to kind of go over what class we're starting with, and then we're going to convert that into a functional component. So we've got a product component. It's got this product state. When it mounts, we're going to fetch the product based on our product ID prop. We need to lock it because this is an editing interface, and so we're going to lock the product so that nobody else can edit it while we are, just make it a little more potentially real world. And then we need to set it in our state so that we can access it in our render. When the component unmounts, if we have a product, we need to unlock it. And whenever the component updates, we need to compare the current product ID or the new product ID with the old product ID and see if they've changed. If they have, we need to get our new product, again, lock it and set it. But before we can do that, we need to see if we have a current product, unlock it, and clear that state first. So that's pretty much everything we're doing in here. Our render is just returning null if we don't have a product, and then just printing out the product name. So we're going to turn that into a functional component. So we're going to have the same React and product service as we did before, though we won't be needing component. We do know that the product is going to take a product ID prop. I like to destructure. You can do that. You don't have to do it that way, but I find it a little bit cleaner. And our render is going to do the exact same thing. If we don't have a product, we'll return null. If we do, we're going to print its name. However, we don't have this .state anymore. We have to get that product somewhere. That's what the use state hook is for. The use state, sorry, I don't type while I talk very well, apparently. Use state returns an array. The first value is, or the first item is the state itself, and the second one is the setter. So if we were to run this right now, it would work. It would return null, it wouldn't do anything, but it would be fully functional. Now we need to start bringing in this extra logic. How do we're gonna need to fetch a product, lock it, and then set it to our state. As I mentioned before, when we're doing those sort of asynchronous side effect things, that's what useEffect is for. One unfortunate problem with useEffect, I don't know if it's a problem, just the way it works, one unfortunate thing is this function cannot be asynchronous. I like to use async await. If you were using promises with .thens, you wouldn't need to do this, but since I'm using async await, I do have to make wrap that logic in an iffy so that it can run on its own without returning a function, or without returning a promise rather. And we have a slightly new way of setting the product. Instead of setting set state with an object, we just call set product. So you don't have to worry about anything else that's in there because it's its own state. If we were to run this now, it would do almost what we want it to do. When the component renders, it's going to see this useEffect, which is going to run on every render. So each time it renders, it's going to fetch the product. Oh, product ID is no longer in props either. It's going to get the product, lock it, set the product. The one problem, though, is this currently runs on every render, and calling set product triggers a new render. So we're actually at this point stuck in an infinite loop. So we need to get out of that. So the first impulse that I see a lot of people doing here is to check to see if we have a product. If we don't have a product, then we want to fetch it. However, if the product ID changes, we also want to fetch. So we stick that same comparison we have here. If product ID is not, except we don't actually have our old product ID. We don't have that old props anymore like we did. We could use a ref to save it and compare it and update it as we go, or we could take a step back and realize that we're thinking about it the old way. We're using hooks to do the old lifecycle callback style. We don't need to do that. We just need to use the second argument to useEffect. This is the dependencies array, sometimes called the inputs. If you don't specify second argument, useEffect will run on every render. When you specify the argument, it only runs when the contents of this array change. So it always runs on mount because there was nothing defined before and now there's an array. But if we pass an empty array, it will only render on mount, or only rather run on mount. So in this case, our product would be fetched, we would show the name. But if you change the product ID, it won't refetch the new product. So we're like halfway there. If we put product ID in here, it will run anytime the product ID changes. So it runs on mount because there's new dependencies. And then again, anytime product ID changes. So now it's updating properly, but it hasn't unlocked any of our old products. So that's what the cleanup function is for. Within useEffect, if you return a function, that will run each time this code needs to be effectively undone. So on the first render, it'll run this, and it'll just cache this function in memory. Then if you unmount the component, it will run this function as a cleanup. And if the effect needs to run again because the dependencies have changed, it will run the cleanup function, then it will rerun the new function. So they're tied together. This cleanup function will run with the code that it returned from. So in this case, the cleanup we need to do is to unlock it, except it's not in state, it's just the value. Except we can't actually access product because it's trapped inside this asynchronous iffy. So we can just pull that outside. And however, if we unmount before this all finishes, we don't actually have a product, so we do still need that if product check, only unlock it if it exists. So when the component mounts or when product ID changes, it'll run through this to fetch it, lock it, set the product. When the component unmounts or right before the product ID changes, it's going to unlock, and we need to set the product to null in between as well. And that is it. This code on the right does everything this code does on the left, but there's no duplication. The final step for me here is say we want to use this product over multiple different components. We can take that code, create a new function, drop it in, and return the product. Then up here, product equals use product with our product ID. Still does the exact same thing. We just taken that logic, moved it to a different function, just made it shareable. But because of the way hooks work, we can use this use product in as many components as we want. We can use it several times in the same component if we have two different dependencies. Everything still works. As usual, we have several resources. We've got on our Bitovi YouTube, we've got all of our past talks. I mentioned 2 of them in this presentation, but we've got, I don't know, 8 or 9 at this point. The official hooks docs documentation are very useful. They're very terse and quick, so it's easy to find what you're looking for, but they've got examples. We've got our Bitovi community Slack that I'm sure Chasen will mention at some point in the future as well. We've got a React specific channel, but we've also got channels for Angular. Pretty much anything JavaScript related, you can find some help for it in there. And then we've got our React consulting. If you head over to bitovi.com, if you need some React help on your current project, if you just need some consultation, if you're looking to hire, we can help with all of these things. Any questions?
I have a question. Could you go back to your code where you had like the split view, where you have the final thing. So you separated out use product to a separate function, and that can be put anywhere. And say you had 15 components on the page that were using this use product. Whenever they mount, is like whenever the page renders, or that all of those different components render at the same time, is that going to send out 15 separate requests to a product service?
Yes. Okay. So each time you use that use state hook, which is just being proxied through our use product hook, it gets its own independent context. So if you were to call this 15 times with different product IDs, you would get, or even with the same product ID, you would get 15 requests to your backend.
Got it.
If you wanted to get some sort of functionality to prevent that, my suggestion would be to put that into your product service itself, put some throttling in there, or some timing, some caching, so that it doesn't fetch the same product more than once. But I would move that logic out to your service layer rather than directly in your React code. But there are probably ways you could do that. It would start to get stateful and get a little messy to do that in the component, in the React code itself, but you probably could.
Yeah, I think service layer is probably the best place to put that too. I agree. I was just curious if it did anything.
Each instance gets its own copy of everything, so they're not like, because use state is not shared between components, even though our use product is called in multiple places, they're all independent of each other.
Yeah, makes sense.